All right, hello. It is noon my time, so I'm going to get started. Um, I would like you to mute yourself until it's time for questions, and there will be times when I'll ask for questions. Uh, but I'm just going to go ahead and dive on in. I think I'm recording this, so I will provide for all of you who signed up a version of the recording when this is done. All right. So I am Shane Ross. I'm a professor and also graduate director of the engineering mechanics program at Virginia Tech. And we're just going to go through some of these slides, and then I will take some questions. At about the 15-minute mark, I'm going to start talking about research labs, specifically those that are recruiting. And these would be names that you would write down when you fill in your application if you're going to do a master's thesis or PhD, and there's specific faculty that you'd like to work with. All the faculty that I mentioned are recruiting, and I do believe they have funding to support students. All right, so I'm talking about the engineering mechanics program. It's distinct from mechanical engineering. So if you think this is mechanical engineering, it is not. Engineering mechanics is a different program at Virginia Tech, and it comprises the areas of fluid mechanics, solid mechanics, dynamics and control. We also include biomechanics and computational methods. You can think of it as where physics and applied mathematics meet engineering, and we pride ourselves on being both fundamental and rigorous. It's got applications to many other areas of engineering and even outside of engineering. So we have students who work in application areas of mechanical engineering, aerospace, biomedical, even electrical, biology, material science, and civil and environmental engineering. In fact, they go on to jobs in those industries as well. So whether you have a background in mechanical engineering, which most of our incoming students do, or a related field, including physics or math, this program will ground you in the fundamentals of engineering mechanics to prepare you to develop new knowledge, to address new challenges, and also communicate effectively. So we've got some core material that at least our PhD program, I'll go through later what the details are for that, but there's some core material that everyone has to get through. But just some areas of application. We've got complex systems analysis, composite materials, structural analysis, occupant vehicle interfaces. So that means how you interact with your car, air pollution, animal biomechanics, human biomechanics, adhesion science, robotics and autonomy, energy engineering, aerodynamics, biomedical technology, bio-inspired design, and even agricultural technology. And I'll say a little bit more about our four main pillars of research area. There's dynamics and control, and this includes work in nonlinear dynamical systems, reduced order modeling, optimal control, biodynamics, coordinated control of networked multi-agent systems, and development and evaluation of automotive systems, as well as big data analytics. We have a group looking at fluid mechanics, and current research in this area includes microfluidic devices, as well as environmental and ocean and atmospheric flow analysis. There's biological applications, so interstitial fluid flow and fluid movement in the body, biological flow systems, and also other transport processes in complex flows. We have people looking at solid mechanics. So this includes theoretical and applied projects. So smart structures, structural mechanics, functionally graded materials, acoustic fluid structure interaction, vibrations, energy harvesting, and also soft matter, and then some biological applications like soft tissue mechanics and mechanics of ligaments and tendons. We also have people looking at biomechanics broadly defined. So not just human biomechanics like musculoskeletal biomechanics related to sports or injuries, but also topics related to animal biomechanics, bio-inspired engineering, locomotion, even plant biomechanics, cellular mechanics, and disease spread. So it runs the full gamut. What have graduates done with their engineering mechanics degree? Just to give you an idea, we do have a lot of students who they appreciate their broad fundamental background that allows them great flexibility. So we've had people in industry jobs, government and academia. Just a few examples. The industry jobs range from kind of conventional ME, aerospace, and civil industries. So that includes SpaceX, Boeing, Pratt & Whitney, ExxonMobil, Ford, Mitsubishi, Michelin, Volvo, Sunoco, Intel, Dow, Nike, Torque Robotics, but also people working in government and government labs. A few highlights: the U.S. drilling manager for ExxonMobil is a graduate of our program and also is one of the directors of the U.S. Department of Homeland Security. We also have people who are become founders and CEOs of their own companies, and several who have gone on into academia, and I'll say more about that later. Just to highlight a few alumni, Michael Hayes is a vice president at Engineering Systems Incorporated, and he appreciated that his engineering mechanics PhD gave him a background in both mechanical engineering and material science. So he looks at failure analysis and product research and development and leads a large team of consultants. He's also been an expert witness and worked at Michelin Corporation and been a professor at Georgia Tech. A student who's now in government, Jimmy Fung, was a master's student here. He went on to work at Los Alamos, where he's now project lead for developing a multi-physics simulation related to fluid and solid mechanics, and also radiation, hydrodynamics, and plasma physics. And he did formerly work for NASA. In academia, there's Suzanne Smith. She is a 1988 alumnus, PhD in engineering mechanics. She's now at the University of Kentucky. She's formerly been at Clemson and was at Virginia Tech here for a little while. Her research areas include aerospace applications. I know recently she's been looking at autonomous vehicles and their use for weather prediction. She's also done work on flexible nonlinear structure, structural analysis, system identification, and vibration testing and composites. And so speaking of an academic career, if you are interested in an academic career, we do have a high faculty placement rate. About 1 in 3 of our recent PhDs are currently professors, which is 3 times the national average for engineering programs. We think it's because we produce thought leaders who build off their fundamental knowledge to create new research areas. So we've got alumni who are faculty at Harvard, Penn State, Georgia Tech, Columbia, Yale, UCLA, NYU, UNC, Texas A&M, Purdue, Clemson, and the list goes on. So no matter where you end up, you'll probably be taught by one of our graduates. Like several of our faculty have also written textbooks. So if you've taken a course in statics or dynamics written by Miriam and Craig, Craig was a faculty member here until a few years ago when he retired. Just to give you an idea of some graduation statistics, in this past year we graduated 20 students, so that's 15 PhD and 5 masters. Most graduates are going on to academia, so about half of them are in postdocs or faculty positions, and this is just from the immediate past year. Others have gone on into industry, about 30%, and then 20% have gone into government or government labs. And just to give you an idea of where they are, I've got the list there. So Berkeley, Michigan, Colorado, Korean Institute of Science and Technology, as a government lab, Los Alamos, and then some companies, Altair, Cooper Tire, Systems Engineering Group. There's a few others I know about. Someone went to Ford. There's others. We ask our students when they graduate, how would you rate your overall experience in the EM program? And this is an anonymous survey, but we get pretty good responses. So 90% of them have said that they had an excellent or very good experience during their time here. So we think we've got a good program. We're placing people in the jobs that they want, and they really enjoy it. So why choose engineering mechanics at Virginia Tech? I'll just give you some answers from current students. They're our best ambassadors. They say there's unique research here that you don't find elsewhere. the interdisciplinary nature of the department. The potential impacts of research to society are vast. They like the atmosphere and the passion that everyone has. You can come here and feel like both a scientist as well as an engineer. We have people who are studying fundamental issues in nature, and they even publish their works in the kind of the highest science journals, like Science, Nature, Proceedings of the National Academy of Sciences. There's also a helpful environment of sharing equipment between labs, and people are friendly. That's good. All right, I wanted to stop here and see if there are any questions so far before I talk about the labs and faculty that are looking to recruit. So are there any general questions? If you have something that's very specific to your situation, you should probably just send that as an email. But do you have something general? Go ahead and ask. Is there anything? No? Okay. I'm going to share another screen now. Okay. So these are the faculty and labs that are recruiting. Like I said, if you fill out the application form, you'll be asked for what are your top 3 research areas and what are the top 3 faculty who you're interested in working with. And so these would give you the names to list and also faculty to follow up with an email if you want to know what more about the specific projects. So Jonathan Barreco, Professor Barreco's lab studies nature-inspired answers to critical water and energy resource needs, such as learning how to harvest fresh water from seawater by taking lessons from the mangrove tree. And Dr. Barreco is currently recruiting new students. See now if I can get this out of the way so it's easier to pay attention. Nicole Abade, there we go. Nicole Abade, her lab seeks to understand how groups of agents may coordinate and cooperate to find better solutions to engineering problems. And they take inspiration from biology. For example, designing collaborative mapping algorithms for robot swarms inspired by data from wild bats. Their work focuses on multi-agent systems, and they're interested in how groups of agents can collaborate, whether intentionally or not, to get some desired global behavior. So these systems are decentralized, so no one agent is in control, and often have dynamics that emerge spontaneously just from simple interaction rules. So some specific systems they study are animal groups, neural networks, and robot swarms. And you can see some description there. Rolf Mueller's lab, the Bio and Sonar Inspired Science and Technology Lab, well, bats are a model for how to sense and navigate successfully in complex natural environments. So the lab studies biosonar sensing of bats and their flight in detail and develops robots based on insights obtained from the animals. He's also looking to recruit. Jake Soha runs the Soha Lab, and the Soha Lab studies animal locomotion and emergent physics of biological systems, like the unusual aerodynamics of flying snakes and internal flows of insects and other questions about animal biomechanics. So he's got a few example questions here. He's usually driven by some fundamental question about mechanics of animal locomotion or fluid flow. So how do frogs hop on water? How do ducks land on water? How do insects use compressible tubes to breathe? How do snakes fly, land, and cross gaps? And how do insects circulate blood? My lab, the Ross Dynamics Lab, specializes in applications of nonlinear dynamics, performing mathematical modeling, simulation, visualization, and experiments with applications in several different fields, including patterns of dispersal in oceanic and atmospheric flows, passive and active aerodynamic gliding that involve strong coupling between translational and rotational motions, also dynamic buckling of flexible structures, and more general dynamical systems theory about high dimensional phase spaces and how they organize behavior of mechanical systems. Oops. Rafaela DeVita runs the Stretch Lab for soft tissue research, experiments, theory, and computation. So the Stretch Lab focuses on characterizing the mechanical properties of biological systems, ranging from cellular components to tissues, with a special emphasis on the development of new mathematical models and experimental methods. The lab is advancing fundamental and mechanistic knowledge of biological systems that is crucial for the development of effective interventions to prevent and treat illness and disability. Dr. DeVita is currently recruiting new students, of course. James Hanna runs the Hanna Lab. And so his lab focuses on classical mechanics, dynamics of equilibria of flexible bodies, geometric nonlinearities in solid and fluid mechanics, curve and surface motion, action principles, elasticity of thin objects, fluid structure interaction, discontinuities and defects, nonlinear waves and oscillations, soft matter, and materials science and processing. And he is looking for new students. Scott Case runs the Materials Response Group, and they specialize in characterizing performance and durability of engineering materials and structures. Examples include energy-absorbing structures for automotive applications, structural fire response, impact damage, and manufacturing of advanced composites. And he is currently recruiting both master's and PhD students. So he has funding for students at both levels. Ramesh Batra runs the Batra Group. They do modeling and simulation of complex systems. His lab studies multi-scale analysis of multi-physics problems involving material and geometric nonlinearities. They do nanomechanics, as well as dynamic failure under shock loads, smart structures, and functionally graded materials. And Dr. Batra is currently recruiting new students. Reza Mirza Afar runs the Multi-Smart Lab, and they study the mechanical properties of different materials at multiple length scales. Mechanical properties that they observe at the macro scale all originate from deformation mechanisms at smaller length scales. To track the mechanical properties across different length scales, they utilize a combination of theoretical, computational, and experimental methods at atomistic, micro, and macro scales. These methods are implemented to investigate the mechanical properties of metals, metal-based composites, 3D printed metals, bio-inspired design materials, polymers, and biological materials such as cells. And Dr. Mirza Afar, he may not appear, he's a new affiliate of the Engineering Mechanics graduate program, so he might not appear in the drop-down menu if you fill out the application. So you would need to email me and him to let me know that you want to be considered by him. Yeah, what we do with when you apply is everyone that you list will definitely see your application. So it's not just one graduate committee that looks at your application, but everyone that you list as a faculty member you'd like to work with does consider your application as well. So they get to see all your materials. All right. Now this doesn't give a name, unfortunately, but this is Rakesh Kapania. That's Kapania. He's in the aerospace department, but he has mentored almost 10 engineering mechanics PhD students. He seems to like our students. He runs the Computational Structural Mechanics and Unitized Structures group. He studies structural mechanics related mostly to aerospace applications, so finite element analysis of nonlinear analysis of plates and shells, shape sensitivity analysis of aeroelastic response, statistical analysis of structures, and neural networks and genetic algorithms. He's looking for new students. Dr. Zach Dorsef is the director of the Center for Advanced Automotive Research at a nearby center called VTTI, which stands for Virginia Tech Transportation Institute. It's a large facility right next to campus that does research related to vehicles. His specific lab, the Center for Advanced Automotive Research, focuses on solving challenges associated with integrating cutting-edge technologies into the vehicles of tomorrow, and he is currently recruiting new students. Also, another faculty member who runs out of the Virginia Tech Transportation Institute, Dr. Miguel Perez. He runs the Center for Data Reduction and Analysis Support. They leverage data, particularly analytics and visualization, to obtain insights that improve the safety of surface transportation systems. So I think, for example, one of the things they do is they've got cameras in hundreds of cars driving around the country, and when there's an accident, they collect a lot of data from each specific accident to find out exactly what people were doing, where they were looking, where their speed was, maybe even what other drivers were doing at the same time, so that they can design control systems that can avoid collisions. Dr. Omar Berry runs the Nonlinear Vibration and Intelligent Systems Lab, which specializes in vibration control, energy harvesting, and smart materials and systems. The goal of this lab is to create novel modeling, analysis, and design techniques for the discovery of emerging technology with applications in the energy, healthcare, and civil infrastructure sectors, as well as in the manufacturing and automotive industries. And Dr. Berry is currently recruiting new students. He's also a very new affiliate, so he would not appear in a drop-down menu in the application, so you, again, would have to email both him and me to let us know you want him to consider your application. All right, I've got another faculty member. Let's see if I can get that to work. Yep. So this is Professor Pablo Tarazaga. The Tarazaga lab works in the general area of structural dynamics, smart materials applications, and adaptive structures. His research interests are structural mechanics, dynamics and control, intelligent material applications, structural acoustic interactions, power energy harvesting, model updating, model reduction, and model validation and modal analysis. There's a video here showing two modes of a building. We've got a building on campus, a 4-story building called Goodwin Hall. And this was built only a few years ago. And at the time that they built Goodwin Hall, Dr. Tarazaga asked them to put in accelerometers at strategic points throughout the building so that he could get things like the vibration modes, the fundamental vibration modes of the building, which are shown here highly exaggerated. It doesn't move that much. But Goodwin Hall is one of the smartest buildings in the world because of this technology where they're able to track vibrations to the point where they can follow somebody walking down a hallway just from the vibration characteristics. They're also doing things like using vibrations to create mixing of fluids. So this just shows some modes where they'll be kind of vibrating a container to trigger a certain flow that they're visualizing with little bits of paper on top of the water here. So creating flow using vibrations of the outer boundary. So those are the faculty that will be that are recruiting. I'm going to get back to my original presentation here. Are there any questions so far? Questions about the labs that are recruiting? Nope. Let me see if there's any questions in chat. I'll have to get to that later. Yeah, if you just joined, I won't necessarily be sending the slides, but I'll be posting this video online, and we'll be sending a link to the video to everyone who's participated. All right, just to give you an overview of Virginia Tech, this is about what it looks like this time of year. The leaves change color, and it's really beautiful. It's a large campus it's a rural setting. We are about a 4-hour drive from Washington, D.C. We're in the southwestern part of Virginia. We've got about 2,000 faculty, and then over 30,000 students. So 27,000 of those are undergraduate students, and then 6,500 graduate students. We've got over $500 million in research expenditures each year, and we produce about 5,000 scholarly publications each year. Just to give you some graduate student numbers, the total graduate student population at Virginia Tech is 6,600, and about a third of those are College of Engineering graduate students. The Engineering Mechanics program has about 70 students. At steady state, it's about 55 PhD students and 15 master's students. And we have about 25 professors that advise these graduate students. Some of our facilities, the main facility, the place where I'm sitting right now, is Norris Hall. So that's where most of the faculty reside. It's got about 70,000 square feet. We've got research labs and offices. Another main building is Kelly Hall, which is just a 30-second walk away. One of the off-campus facilities, but it's relatively close, and there's a shuttle that can take you there. I mentioned it before, the Virginia Tech Transportation Institute. This is a place that has, I think, 500 employees, but also students who do research projects related to automotive technology, especially autonomy, are working out of that. So, for example, there's a closed course where they're testing out new vehicles like Teslas and other experimental vehicles by having cutouts of children jump in front and see if the car will respond. They can also create any weather at any point. So they've got this system of hoses that can create snow or sleet or rain, even in the middle of summer, for testing out how vehicles respond in those weather situations. We've got a high-rate biomechanics lab. This is for studying car crashes and other things related to injury biomechanics. There's also the biocomplexity building where some biomechanical modeling is done. All right, let me give you, I'll first talk about some milestones in the master's program and then milestones in the PhD program. The details for each of these programs are online on our website, but I'm just going to run through some highlights. So if you enter the master's program, you have to take continuum mechanics. So that's ESM 5014. Our numbering system is such that 1,000 through 4,000 are undergraduate courses, and then 5,000 and 6,000 are graduate courses. So continuum mechanics is required of everyone who does the master's program. And then things, you get some flexibility. You have to take 6 credits. Each course is 3 credits, so this means 2 courses. You need to take 2 ESM graduate courses in one of the 2 following areas. So solids, fluids, and I don't know why we didn't write dynamics, but we say motions. So for example, you could take 1 course in solids and 1 course in motions, and that would fulfill that requirement, or 1 course in fluids and 1 course in solids. We also require a graduate level math course, which means any course taught by the math department at the graduate level. We also allow, there's a list of engineering courses that have significant math content that we'll include for that requirement. Then things depend on whether or not you're doing the thesis option or the non-thesis option. If you're doing the thesis option, you'll have to do 9 to 12 additional credits. So that means 3 to 4 additional courses of graded coursework. If you're doing the non-thesis, you'll have to take 18 credits, which means about 6 courses. Also, if you're doing the thesis option, we make up for the difference in credits by you get research credits for during your thesis research. And all of that adds up to 30 credits, which is the minimum required by the university regulations for you to get a master's. We also require 2 semesters of our seminar. The seminar is just 1 hour per week. You have to complete the ethics and integrity requirements. If you are doing a thesis, you have to identify a faculty advisor and advisory committee members. And it'd be tough to get through all of this in 1 year. So you could try, and it is theoretically possible, but it is tough. So usually people will take a second year, especially if they're doing the thesis master's option, in which you're doing research, and then you'll do your final defense and then graduate. So some important milestones in the PhD program, it's a bit different. We have core courses that we require. So we require intermediate dynamics, and this number over here is the number of credits it is. It's 3 credits. This is a course that does Lagrangian and rigid body mechanics. That we also require continuum mechanics, and this is during the fall semester. So it's ideally you enter during the fall semester. So you could take these courses, and then during the spring semester, you take the rest of our core courses, which is an intro to solid mechanics, intro to fluid mechanics, which use the sort of notation and flavor of the other 2 courses. We also have a scientific communication course, which teaches you how to give good presentations, how to write abstracts, how to write papers, how to start the discussion on authorship issues, whose name goes where. So that's kind of a special part of our program that gets some added benefit to you. It doesn't have a lot of technical mechanics content, but it gives you soft skills that will help you later on. Then there's 21 credits of additional coursework, and there's usually a lot of flexibility here. It just needs to be courses that you want to take and are related to your research, ideally. You need to complete the ethics and integrity requirements. Since it is the PhD, we require that you get a faculty advisor and advisory committee members. Our committees have 5 members on them. There'll be a qualifying exam based on the core course material, so just those 5 courses. But there's an important caveat. You can be exempted from the qualifying exam if you have strong performance in these core courses, which students have told us is a good feature of the program. So if you get a B- or higher in each of these courses and get a 3.2 GPA overall, then you get exempted from a qualifying exam. So in the past few years, we haven't had many people take the qualifying exam at all because they're doing well in these core courses. That's during the first 1 to 2 years. After that, the next thing you do is you do what we call a preliminary exam, but really it's your doctoral project proposal. So this involves just presenting. You've already established your committee. So this is sometimes the first meeting of the committee, and you first give them a written document, could be 10 to 15 pages, proposing what you will do for your doctoral research, and then presenting what you would like to do. It often includes giving a literature review of past work, and then what you would like to do. And we request that this be done within 12 months of passing the qualifying exam. So that usually means within 12 months of finishing your core courses. So this is usually done in the second year. And after that, you're just doing research for a few years and then doing your final defense. I can give you some statistics on the amount of time it takes to finish the PhD. If you come in with a master's, it typically takes 4 years to finish the PhD. If you come in without a master's, and we do allow that, if you come in with a bachelor's, you can do the direct PhD option, but it usually takes a little bit longer, 5 years to get the PhD. And then once you've finished all that, your name is here on the diploma, and you get your Doctor of Philosophy in Engineering Mechanics. So just to give you a review of what the typical first year will look like, the fall semester, you'd be taking continuum mechanics, dynamics, and then maybe another elective seminar, and then doing research if you're pursuing thesis. Spring semester, then you would do, this is a typical first year for the PhD student. There's more flexibility if you're a master's student. But for a PhD student, you take Intro Fluid Mechanics, Intro Solid Mechanics, the communications course, again, the seminar, and then research. And then that first summer, after you're here, you would be doing research if you're pursuing a thesis. Let me talk about funding. Funding is typically provided through assistantships that are tied to faculty projects. So this is for PhD students primarily, but some faculty do provide funding to master's students. So for example, Dr. Scott Case is one that has projects where he can fund a master's student. A typical assistantship looks like this. So you get a stipend of about $2,200 a month, which gives you about $26,000 a year. It covers tuition and fees and 90% of health insurance premiums. There are two types. There's the GRA, which most first-year students will be given, and it'll be given to them by the faculty advisor. GRA stands for Graduate Research Assistantship. That means you're doing 100% research and getting paid for it. There's also GTA, Graduate Teaching Assistantship. This usually is only for second years and later, and they assist with laboratory courses, grading, office hours, and lectures. There's also help provided by the graduate school through the Academy of Excellence on how to, they give workshops on how to be a GTA. There's some additional benefits to our program. We have graduate student awards and fellowships of about $50,000 given annually in awards and fellowships. This is to recognize excellence in scholarship, research, and service. This isn't something that you coming in as an incoming student would have access to. We give these to current students based on work that they've done while here. There's also a graduate student travel fund that is available just to our own graduate students so that they could present research at conferences. We also have a Graduate Engineering Mechanics Society, and their acronym is GEMS. And this is a student group that puts on social and career development events throughout the year. So these could just be social events, get together at a restaurant, or at a potluck. The career development events could include meeting alumni, so networking with alumni, learning how to write a good resume, or maybe something more technical like using LaTeX to write papers, or using Python for scientific computing. We also have a related program. It's called the Biological Transport IJEP. This isn't a PhD granting program, but this provides a supplement for those who enter our program but are interested specifically in biological transport. So it combines both engineering and biology. You need to be co-advised by a faculty member in engineering and also one in the life sciences. So for example, if you came here, you'd need to find an engineering mechanics advisor and maybe an advisor in biology. The nice thing about this program, if you get accepted, is that it provides funding for that first year, and you also get to do 3 7-week research rotations prior to choosing advisors, which means you get you do a research projects that takes 7 weeks where you get to work in a lab, and then you get to do another one in someone else's lab before you decide on choosing an advisor. So if you're interested in this topic, and I would say go to this website if this interests you at all, you would still apply to the engineering mechanics program, and then there's some separate application form for getting into this program as well. So once you're in, you are considered a Biotrans affiliate, and you get support through, I think, travel support and also other programming for your entire PhD career. I didn't say it, but this is only for PhD students. And the director is currently Jake Soha, who is a member of our department. All right. Are there any questions?
Hey, this is Hamed. So I got a quick question.
Yes.
Do you have any statistics that show that how many hours a day that a PhD program may take? I mean, just an average per person.
How many hours a day does what take?
The PhD program, I mean, the studying and all that for a person. I mean, how can you picture a daily life of a PhD student?
I see. Okay. Like, what do they do on a daily basis?
Sort of thing.
Yeah. You know, I know for the new students, they'll be taking 2 or 3 classes, which means on any given day, maybe they're just in 2 hours of classes, and they're spending much of the rest of the time working on homework or doing research in the lab. People keep all different kinds of hours, so it's hard to say the standard. But I would say on average, people are putting in 40 hours a week. Right, so it's like a full-time job. We're talking about full-time student status here, where if you're not working on homework, you're in the lab working for your professor.
Yeah, I see.
Yeah.
Thanks.
Okay. Anything else?
Again, I'm a civil engineer.
Okay.
And I'm interested in those data analytics part of research. So is it possible to get some computer science courses and stuff? Is it a normal thing for students to do there?
Yeah, we've had several people. So as part of I imagine you're talking about PhD.
Yes, correct.
So part of the flexibility, this additional coursework of 21 credits includes, I think it's 12 to 15 credits of any topic you want. So if computer science is the area that you're interested in and your advisor agrees, then you can sign up for computer science.
Yep.
Or civil engineering courses that are relevant. We also have a new, I think it's still only at the undergraduate level. We've got a data analytics major, and I think they have some courses that are kind of co-taught by math and computer science. So those might be relevant as well. But again, I think they're still only at the undergraduate level. You get to, for this additional coursework, if there's an undergraduate class that's relevant, you get to count, I think, at least one undergraduate course towards the course requirements for the degree. And
can these courses funded by those programs and the budgets that each professor has?
These in terms of if courses the course will be taught or not, and it has nothing to do with your own advisor. So you sign up for courses that are available, and typically courses that are taught by a department on a regular basis will continue to be taught. So if you looked at the course course listings under the graduate catalog for computer science, those are courses that they teach regularly.
But I mean, can the budget of the professor pay for those classes, or how to fund those classes?
Okay, I think I see what you mean. If you're on an assistantship, your tuition is paid for.
Oh, okay.
So tuition covers taking a full load, taking 18 credits. So if you're on an assistantship, everything's paid for.
Okay. And do you think it is wise to contact directly each professor and start this conversation with them?
Yes.
Yep.
Yeah, so that they know to look out for your application, and it also helps you know more specifically, what exactly would the project be. So feel free to contact these faculty. And if you didn't pick up a name, again, like I said, I'll be posting this so you can look back through the video and write down the names, contacts of the people you're interested in.
Okay. Thank you.
All right, thanks. Anyone else?
Yeah, my name is Jordan. I just have a question about what's kind of the advantage of getting a degree in engineering mechanics versus in mechanical engineering, I guess, in terms of job opportunities, or like how does that kind of change your prospects?
So what we've heard from students is that it expanded their prospects because they've been able to work in traditional civil or aerospace or mechanical engineering jobs, having the engineering mechanics PhD. Are you asking about kind of master's or PhD or either?
I guess both. I'm a little more interested in doing a master's.
Yeah. If you already have a degree in mechanical engineering and then you add on top of that, you've got a degree in something else, I think at least what we've heard from our advisory board is it makes you look more attractive.
For sure, yeah.
That you've got a more fundamental, broad background, especially when they hear specifically, like, what have you taken? Oh, I've taken kind of fundamental fluid mechanics, finite element analysis. It shows that you are willing to keep up with your technical skills. So we see that it's open doors. We haven't really seen much of a problem there. And of course, we don't have anyone who's got both a PhD or a master's in engineering mechanics and mechanical engineering to compare apples to apples, but that's what we've heard. It makes you stand out because it's a, I guess, a more rare degree.
Sure, yeah. Awesome. Thank you.
All right. Anyone else? I hope I'm not missing anything about from. I see that there's texts. Okay, there's a question. There's a few questions here in the group chat. Suppose you get enrolled in the master's program and later want to continue into the PhD. What is the transition process like? There's just one form you have to fill out, and we've had a few people do this, where they come in, they want to test the waters, so they start with a master's, and then they're able to count all of those courses toward the PhD once they decide they want a PhD. So it's just filling out a form. It's not a big deal. Does the PhD program allow credits for courses taken during the master's at a different university? Yes, we allow you to transfer up to 15 credits, so that's 5 courses, from a different university if there's an equivalent course here. So there's a process by which you have to get the syllabus from the course that you took elsewhere, the syllabus here, and our graduate committee will decide whether there's enough overlap. I forget what the threshold is, like 80% overlap or something. And then we would count that, and you won't have to take that again. So yeah, good question. What is required to go straight from the bachelor's to PhD? Would I recommend it? Well, we've had several people do it. You just have to have we do expect you to have a strong enough background in physics and math, essentially. So we've had people who come in with an applied math degree and still complete the direct PhD. It may be harder. I mean, if you haven't taken the sort of traditional engineering courses of statics, dynamics, and deforms, there'll be a learning curve. But I think if you've got an engineering bachelor's, it should be easy, and physics, I think you'd do fine. Are all students required to be full-time? Would we consider accommodating working professionals who want to pursue a PhD? Right now, we only have full-time students. I think there are programs that allow part-time PhD. But it would be hard if you're not on campus to take our core courses. The core courses are currently not online, so you have to be in the classroom. So there could be, we have had the situation where after students have finished all of their coursework, they, as long as they can get their research done, they don't have to come to campus. So they could possibly live elsewhere. But that's more in years 3 and 4. And then they come back and defend, and they're finished. I think I've answered everything. Maybe I forgot some stuff at the beginning. Yes.
Well,
Yeah,
hi,
go ahead.
this is Bhargavi.
Hi.
So what is the sense of, is there much of a sense of community amongst the master's and PhD students in this program? I've heard at my school, at least, there isn't much amongst the master's students, but there's a lot of sense of community between the PhD students. Wondering, is it a nice place to get to know people?
Yeah, and it's not like there's a big division between the master's and PhD, and one group hangs out with one and not the other. In fact, we've got, if I could show this to you, our Graduate Student Society has its own website, and I think it might be good to see. Hold on. Is it? Okay. Let me do a new share screen here. It's kind of hard to find this by just Googling it, but gems-esm.wixsite.com. This is the Graduate Engineering Mechanics Society website. So it's put on by the students. So there's, you could ask Kristen, she's the president. I don't know why they don't have pictures of everybody, but these are the pictures of the leadership team. They even put together a frequently asked questions to answer things like, what is engineering mechanics? What can you do with a degree? They have put on events and they hang out. These are kind of organized events, but of course there's things that just happen spontaneously. But there's, I would say, a pretty good sense of community, especially because most people are in the same building and their offices are right next to each other. And everybody has to take at least continuum mechanics together, and that's a bonding experience. And most people take both continuum and dynamics together. So through the core courses, that's what sort of builds up community, and then you maintain those bonds through the years. Of course, if you're a master's student, you'll be gone in 1 to 2 years. But if you're a PhD, you'll be around for a while. But there is a pretty strong sense of community, and there are events that bring people together. We have recruiting events, and that brings everybody together at least twice a year. There's events that involve faculty as well, so there's opportunity to not only hang out with other students, but with faculty. So I would say, okay, yes, there's a sense of community. Plus, if you want to, you could even fill out a form and contact one of our current students directly, and they can let you know what things are like from their point of view.
Sounds good. I have one more question.
Okay.
So there are 4 distinct areas of study or of research in this program. And I'm very interested in dynamics and fluid mechanics, and I'm still not sure which to pursue. Is there any way to kind of test the waters? I have a bachelor's in mechanical engineering, and I guess I'm still trying to figure out what to do.
Okay. Well, you don't. So are you saying you don't know kind of which faculty member you'd want to work with?
Yeah.
Right from the get-go?
Yeah.
If there's a few different labs that you might fit in, and that's why we do ask for you to list more than one faculty member, there's possibly a way that you can go through that first year and sort of do small projects in each of the labs to try to find out where you would be the best fit, and then decide by the end of year one. So if you're not sure between fluids and like dynamics, we have some students who get into that situation, and then they usually have picked an advisor by the end of their first year.
Okay, that sounds good. Thank you.
All right. Any other question? Hope I'm not missing any important texted questions. All right. If not, then we'll sign off. Maybe I'll stop sharing my screen. And thanks for coming to the online seminar. If you have other questions that you think I could answer, you could email me. You can find me on the website. I also probably have me in your email box, but shaneross@vt.edu. Also, like I said, I encourage you, if you're interested in any of those faculty, to email the faculty directly to find out what would be a good fit, and then send in your application. The sooner you send in your application, the better. We do have a deadline of January 11th, but if you send things in sooner, faculty start looking at the applications as they roll in, and some of them start making decisions early because they want to make sure someone's in place. So I would say get your applications in early.
Shane, just a quick question. I got to take my GRE, and I definitely cannot do it before January 11. How does that work?
I think you'd have to just leave it blank, but definitely get your application in before the 11th, and then once you have a GRE score, somehow notify us, send that to us.
Yeah, I do have an outdated for 2012, but yeah.
So you could either list that one or just leave it blank and let us know somewhere on the application form that you'll be sending the GRE later.
Sure.
Okay. All right, if that's it, then I'll be signing off. Are there any more questions? No? Okay. All right. Thank you all for your time.
Thank you, sir.
All right.